To talk about sound. Now there are some fundamental physical quantities. These are super important. They're how we base all of our measurements. They include length, mass, and time. Every other quantity can be described or derived from these three fundamental quantities. And in science, the metric system is used. So length is measured in meters, mass in kilograms, and time in seconds. Length is a measure of distance, the amount of spatial separation between any 2 points. 1 meter is the distance traveled by light in a vacuum during 3 × 10 to the -9 milliseconds. Length could be a centimeter, which is 1/100th of a meter, a millimeter, 1,000th of a meter, or a kilometer, 1,000 meters. Mass, we already know, the quantity of matter present. We measure mass in kilograms, and a kilogram is defined as the mass of a cylinder of platinum housed at the International Bureau of Weights and Measures. The concept of mass is tied to inertia. The greater the mass, the greater the inertia. So inertia and mass are proportional. With a steel ball and a ping pong ball the same size, which has greater mass? The steel ball. So which has greater inertia? The steel ball. Time, a solar day is divided into 24 hours, an hour 60 minutes, a minute into 60 seconds. Therefore, each day has 86,400 seconds, and a second is 1/86,400th of a solar day. Now, derived physical quantities are a quotient or a product of the fundamental length, mass, and time, or a fundamental and a derived physical quantity. For example, length versus area. If you were to take the length of one side of a box at 3 meters, the length of the other side at 2 meters, the area is 6 meters squared. So the area is derived from the two lengths. For this class, we're going to talk about displacement, velocity, acceleration, force, and pressure. Those are the important derived physical quantities for this class. Displacement, x. It's defined as a change in position, specified by calculating the distance from a reference or starting position to a new ending position. It is a vector quantity because it incorporates both magnitude, which is the distance covered, and the direction. This is different from a scalar quantity, which only considers the magnitude. So a vector quantity incorporates both magnitude and direction, and displacement is a vector. If you look at these three pictures, A, B, and C, the displacement is different for each picture. In A and B, the distance covered is the same, but the direction is different. In A and C, the direction is the same, but the distance is different. Can everyone see? And in B and C, we have both different direction and different distance covered. So these displacements are all different. Velocity is the amount of displacement per unit time, or the time rate change in displacement. Velocity incorporates the distance moved and the direction moved. It is also a vector quantity. Average velocity, it's c, the symbol is c, is displacement, which is a derived quantity, divided by time, which is a fundamental quantity. Speed and velocity are not the same things because speed does not consider direction. Speed is therefore a scalar quantity. So velocity versus speed. Speed is a scalar quantity. Speed is the distance covered divided by the time. Velocity is the distance and the direction covered divided by time. And it can be average or instantaneous. For example, if a motorcycle is moving with an average velocity of 50 miles per hour, the rate of movement has to have varied during a 2-hour trip. That would be the average velocity. Now, if a police officer tagged that motorcycle going at 65 at one moment, and that's over the speed limit, they would be in trouble. So there's an average velocity and there's an instantaneous velocity. Velocity is displacement per unit time. It's a change in distance and a change in direction divided by time, and it's measured in meters per second. Acceleration is derived from velocity. Acceleration is the time rate change in velocity. It is also a vector quantity. The change in velocity in one direction is not the same as the change of velocity in another direction. The magnitude might change, the direction might change, or they both might change. A car traveling at a constant speed in a circle is undergoing acceleration because the direction of the motion is constantly changing. Therefore, the velocity, which incorporates speed and direction, is changing. If velocity changes, acceleration has to have occurred because acceleration is the time rate change in velocity. Acceleration is an increase in velocity, or deceleration, which is a decrease in velocity. And acceleration is measured in meters per second squared. So acceleration, the change in velocity divided by time. A car moving around in a circular track at a constant speed, remember it's accelerating because it's changing direction.